Okay, so we will continue our chapter. So chapter 1, Introduction to Environmental Science. So now we're going to talk about the science itself, because remember, this is environmental science, which is the applied science. When we learn about how the natural system works, plus we will also try to solve problems that may be happening in these natural systems. So this is a type of science. So what is science? Eh, So science is a process for producing knowledge based on observation. So based on observation, we develop or test the theories, okay, which is a proposed explanation of how a process works using these observations. So in the science, there will be observation, there will be experimentation, there will be predictions and other things, okay? So science is also referred to the cumulative body of knowledge produced by many scientists. That's the reason why, yeah, when we learn about science, we do observations, we produce the results. Most of the time, we will share that results in the scientific seminars. Science rests on the assumption that the world is knowable and that we can learn about it by careful observation and logical reasoning. Some basic principles of science. First, empirism. Okay, empirisms mean observation of real and observable phenomena can help us to understand the natural processes. The second principles, okay, science is uniformitarianism. It means that the natural forces at work today are actually the same or similar as those that shaped the world of in the past. Okay, so the natural uh, uh, natural work or natural forces that happening today is very similar with what actually happens on the past. Parsimony, this is very important, which is when we have several explanations, let's say we have two explanations, then in the science, we have to choose the simpler one. Okay, the simpler of two explanations is preferable. Science also based on the uncertainty, which is the knowledge can be updated to the more precise and accurate of new as the new evidence is collected. So the old result, for example, can be changed by the new results with the new evidence. Science also repeatable. It means that the test, the experiment that we do can be repeated whether by us or by other scientists. The proof is elusive. It means that the new evidence can always improve scientific knowledge. So there is no theory considered as finished. So some theory, most of the theory is actually not finished yet until it's become law or principle. Science also based on the testable questions. Question must be testable by experiment or observation with some form of evidence that can be collected to support or disprove the prediction. So these are several basic principles of science. Science depends on skepticism and also reproducibility. think we already talked about this, okay? Ideally, the scientists are skeptical. They are cautious about accepting proposed explanation until there is substantial evidence to support it. Scientists aim to be methodical and unbiased. So unbiased is really important for scientists. Scientists demand reproducibility. This means that the experimentations or the results can be repeated. Making an observation or obtaining a result just once, okay, is just only one, does not count for much. You have to produce the same result consistently to be sure that your first outcome was not a fluke or maybe just a random. Okay? So repeatability or repetition is really important in performing experiment or science. Science use both deductive and inductive reasoning. So what are these reasonings or logical? The deductive reasonings is the reasoning or the conclusion that is taken from general to specific. General to specific. For example, we all know that all organisms have cells. Okay, because of that, then what happened? Fish is an organism. Because what? Because fish consists of cell. So from general to specific. This is what we call the deduction or deductive reasoning. The second type is called the inductive reasoning or induction. This is coming from observations. Like for example, we observe that fish consists of cell. Frog also consists of cells. Snake consists of cell. Okay, they're all organism. Therefore, from these observations, then we have induction or we have the conclusion that all organisms have cell. Okay, so this is from observations to the general conclusion. So that's the difference between deduction and induction. The first step in science is observation. Okay, this is the first step of understanding our environment carefully. Okay, so the detailed observations and the evaluation factors involved in this first step. Okay, knowing about the world we inhabit help us understand where our resources originate and why. So this observation is very important step in science. This is mostly considered as the first step in science. Observations, including question, curiosity, and some other things that we think about how this environment works. So after making observations and identify maybe, the problems, and then we have a questions. Mostly we will formulate these questions with the hypothesis. Okay, so the second step will be hypothesis. For example, we observe that our flashlight doesn't work, doesn't light. And we have a question, what might be wrong? So from these questions, then we can formulate a hypothesis. So maybe our hypothesis like the flashlight does not work because the batteries are dead. Okay, maybe that's the first hypothesis that we create after observation and question. And then in order to answer this or to prove this hypothesis, whether correct or incorrect, then we have to perform the next step, which is experiment or testing. So we test our hypothesis because we said that the flashlight does not work because of the batteries are dead. That what happened? We test by replacing the batteries, the old batteries with the new batteries. And then after replacing that, then we have the results. Maybe the battery is work. It means that if the batteries work, then our hypothesis is correct. But what happens if the battery doesn't work? Then we have to create a new hypothesis. So our new hypothesis may be the bulb, okay, is actually does not work. And then what happened? We're gonna do the next test, okay, the test our second hypothesis, we replace with the new bulb. If still doesn't work, then we continue with the next hypothesis and etc. until we find or we have the conclusions that may be proving our hypothesis is correct. Okay, if we follow this chart, like for example, okay, so the scientific method will always start with the observation. So these observations can be also known as curiosity and then questions. Okay, these include in observations. Okay, from this, then we formulate the second step, which is the hypothesis. So this is the first step. The second step will be the hypothesis. We create hypothesis. And from the hypothesis, we can also create a prediction. It can be third step, or we can just continue with the testing the hypothesis, which is the experiment. So it can be the third step over here. Again, if our hypothesis is rejected, then we have to create another hypothesis, a new hypothesis with a new prediction, with a new experiment, and continuously, okay, until we have the confirmations of our prediction, which is this one will be the results over here. Okay, so the fourth step will be the results. Okay, from the results, then we have the conclusions. And this conclusion can be presented in like a scientific seminar, which is we share. Okay, sharing the result. Okay, that can be the 6 steps of this scientific methodology. So if we see the second chart over here, this is going to be a simpler chart, which is the step of scientific inquiry or methodology. Okay, we start with identify question, which is this one is also known as observation. Okay, and then we create the hypothesis. That's the second step. Okay, and then we perform the test or experiment. Okay, and then we collect the data. Okay, and then this is the also known as a result. And then from that, the analysis or interpretations of the results. And then we're going to have conclusions over here. Okay. And then after that, we usually also report this or we share this conclusion or results with some scientists in maybe scientific seminars, okay, or conference. So these are the 6 main steps of scientific method. So there is some terminology that we also have to learn in science, like, for example, probability. So what is probability? So probability is the measure of how likely, so this is likely, okay? How, okay, likely something is to occur or happen. So this probability does not tell what will happen. So it is not. It is not telling what will happen, but it will tell what is likely to be happen. Okay, so this is kind of prediction what is likely to happen. Like, for example, if you hear that the news that you have 20% chance of catching a cold this winter, that's mean that 20 of every 100 people are likely, not will, remember? So this is likely to catch a cold. This doesn't mean that you will. So this is not, okay? It does not mean that you will catch one. In fact, it is most likely or more likely 80% you will not get the cold. Okay, so this is the probability. So this is measure how likely something is or will be happening. When doing science, there's another thing that we also have to consider, which is the design. Okay, this design of the tests or experimentations. There are several types of experimentations. The first one is called the natural experimentation. And the second one is manipulative or laboratory experimentation. So this is a two main type of experimentation or tests. A natural test or experiment is one that involves observation of events that have already happened in nature. So we usually do not alter, okay, the conditions in the nature. We just perform experimentation or observations in the nature. We might divide the area, for example, control area, the polluted area, or the other type of area that we will or we can observe, but we do not change the conditions on that place or area. The second one is manipulative, which is also known as laboratory experimentation. This is, we have the conditions that can be altered. We can control that condition. And we control also many variables in this laboratory experimentation. So we have the freedom to alter the condition or variables in the laboratory experimentation. For other experimentation, for example, in the medical science, they can also perform blind experiments, which is the researcher itself actually do not really know which people that actually receive the drug, for example, when they perform drug testing. So this is used to reduce the bias. So the researcher will, will not know which person actually or which peoples with the that receive the drug, which people that does not receive the drug. Okay, so the results will be clear and it's not biased. And sometimes they also perform the double-blind experiment. So in drug test, they usually perform this type of experiment, which is blind or double-blind experiment in order to reduce the bias on that result. In each experiment or studies, we usually have what we call the dependent variables and the independent variables. What are these variables? We'll see on the next slide over here. Okay, some terminology. The independent variables are, okay, the variables that are not affected by any other variables that the study measured is not affected by any other variables. This is what we call the independent variables. The second one, which is the dependent variables, are variables that are affected by the independent variables. So these variables, okay, the dependent variable is also known as the response or the symptom or the outcome or the result that coming from the independent variables. Okay, so the variable, the independent variable will affect the dependent variable. Therefore, dependent variable is also known as the response, the symptoms, or the outcome. The next things that we also have to consider is the constant. What is constant? Constants are variables, okay, factor that scientists want to keep the same to avoid biases. So this is the condition that the scientists keep the same or similar. For example, when performing the experiment for several type of groups, so each group will have similar condition. Like for example, if we put it in the Petri dish, then the size of the Petri dish should be the same for all the experimentations. And the placement, for example, they have to put in the same place for the test, for the experimentation. So this is what we call the constants. And the next thing is the control groups, which is the groups in an experiment that does not receive the variables or treatment. And the second one, the experimental groups, are the group that receive the variables being tested or treatment in the experiments. Okay, so we're gonna explains more about this constant, which is this is very important to reduce the bias during the experimentation. Again, constants, the condition that the researcher have to keep the same for all groups in the experimentations. Like for samples, the size of the container, it has to be the same. It has to be made with the same materials. If we use plastic containers, for example, then all the treatment, all the group have to use the same plastic type of container. The place, the place has to be the same. The temperature, so all the group will have or receive the same temperatures. The light, which is lightness or darkness, they have to be in the same condition. The volume, the time. It is 5-minute experiment, and all the group has to be receive 5-minute experimentations and other thing. So this is what we call the constant. This is also the reason why in some laboratory, they have what we call the experimental chamber. This experimental chamber is the place that can be monitored, that can be controlled. The same temperature, the same light or darkness condition. I will show you the example of this experimental chamber. Look at this picture over here. So this is the walk-in experimental chamber. If you see over here, this is the control. The scientist can control the temperature inside the chamber. The scientist can control the darkness, the light. For example, they can change, for example, 16-hour light and 8-hour dark during the day, and etc. The humidity and many things. It can be controlled within or inside this experimental chamber. So many scientific labs, okay, especially the one that deal with this constant or the conditions, natural condition, for example, they can change the condition similar with the natural condition. They usually perform the experimentation inside this experimental walking chamber. The second one, okay, to reduce bias, the first one is constant. Okay, the second one is random. It is also really important. Okay, when we put the groups of the experimentation, then we cannot choose, okay, where we put that. It has to be random. Okay, it has to be random. The placement of member of each group has to be random. We cannot choose all, for example, all control will be on the left side. All the treatment will be on the right side, and etc. No, it has to be random. Okay, some member of the control group on the left, sometime in the middle, sometime on the right. And there is a way to randomize the experiment. Okay, there is a what we call the random numbers, okay, that can be used for making our experiments in the randomized condition. So this is really important for scientists to follow this random rule in order to reduce the bias. And again, as we mentioned before, for the drug test, sometimes, okay, or most of the time, they will also use the blind test and double blind test. Okay, so this is to help them to get the valid results using this type of test, especially for drug tests. Now, the results, okay? So when we perform the experimentations, after we do that experimentation, that what we have is we will have the results. So the results, okay, can be presented in the tables or maybe in the graph. So for the researcher, they usually have the note, okay, or notebook that they can use for writing the raw data. So the raw data is the data that involve everything, okay, that coming from the experimentations. And then from this raw data, then can be calculated into the calculated data. In this case, for example, the scientists will calculate the data, make in average, and etc. And this is usually the one that will be presented in the report, okay, the calculated data. And also the scientists can put the result in graph. There are several types of graph that can be used, maybe line graph, bar graph, or pie chart. These are the three examples that the graph that scientists presented. Okay, for example, this one over here. The first one is the line graph. If you see over here, okay, on the line graph and also in the bar graph, usually the independent variables is put in the x-axis. So if you see the x-axis over here, this is most likely the independent variables. Okay, this is independent variables. The y-axis, okay, so going the vertical axis over here, is most likely will be the dependent variables. okay, dependent variables or the response. Okay, response. So if you see on the first graph, the line graph over here, you see the independent variable is the years. So from 1950 to 2050. And then you see in each year, they have the response. In this case, this line graph show you the total fertility, which is the number of children per woman. So if you see the response in 1950, okay, in the least developed country, okay, there are about maybe 7 children per one woman. And you compare with the most or more developed country, only 3 children per woman. So this is the response in 1950. But if you see when the time or the years going to 2050, the line is going down for the least developed country. Okay, so it is expected that in 2050, okay, in the least developed country, there are only about 3 or 2.5 children per woman. It is reduced from 7 to about 3. In the more developed country, for example, is also reduced from 3 to about 1.8 or 2. And in the average in the world, okay, from 5 in 1950, 5 children per woman goes to around 2 children per woman. So this is a trend that the number of children per woman will be reducing during this year. So when the year from 1950 to 2050, all the trend is showing us the number of children per woman will be reduced. And they might go to the constant or similar numbers over here. There are several factors maybe that can affecting this problem or this result. Like for example, most of the women, they usually more educated, and then what happened? They usually married at the older age. Therefore, their number of children that they have will be reducing. So this is how we read this data from the line graph. How about the bar graph? So this is the data that's showing us the production of the 5 primary greenhouse gases, which is the carbon dioxide, the methane, okay, fluorines, and also nitrogen oxide. Okay, so there are 4 actually over here. Okay, carbon dioxide, the methane, nitrogen oxide, and fluorines. So the carbon dioxide is divided into 2 types, from the fossil fuel, like from the transportation, from the cars, and etc., and also from the deforestation. So if you see the graph over here, again, the x-axis showing you the independent variables, which is years, progressive years, and then the y-axis showing you the response, which is the number of the greenhouse gases produced during that year. In 1970, for example, okay, about 30, and then it's increasing in 2010, close to 50 over here. So it's increased. There's a trend of increasing the production of greenhouses gases. And this one is by the regions or countries, okay, in the pie chart. Okay, so if you see over here, the country that produce most of the greenhouse gases is China, okay, followed by United States, and then we have the European Union, okay, and then India, uh, Russia, Japan, and all other countries over here. So this is showing us which country actually produce more greenhouse gases from this uh, results, okay, which is the graph. So we can put that result again in the form of table or maybe in the form of graphs. We actually will learn this in our first experiments. Again, the science is a cumulative process. This is not individual result. Okay, the scientists all over the world, most of the time they will meet in seminar, okay, to share their results. Okay, so good science is rarely carried out by a single individual that working in isolation. Instead, a community of scientists collaborate in a cumulative self-correcting process. The idea is consensus. So in science, this is a consensus. That's the reason why the result that become consensus is usually known as the theory. So theory is not coming from one experiment, but it is coming from cumulative process. Sometimes new ideas emerge that cause the major shift in scientific consensus, okay, in this theory. Okay? These great changes in the explanatory framework were called the paradigm shift. So sometimes one theory can be replaced with the new theory, with this new idea. What is sound science? So sometimes we know maybe people give opinion. So these opinions, okay, it's a science. Sound science is just opinions. So sound science usually based on the facts. So this is the fact, which is, it is based on the data, okay, experimentations. Okay, so this is the sound science. For example, if you see this graph over here, yeah, so from this graph, you see a lot of result over here, okay? In this graph, you see that the highest index, okay, the country that have higher index, they will have less children death. Okay, so usually developed country, they have high human development index, where the country that have lower HDI or human development index, usually least developed country, they have higher mortality death of children. Okay, so it's going down. So this is actually this data showing us the negative correlations or regressions between the SDI index and the child death rate in that country. Okay, so this is a sound science. Why this is sound science? Because this is based on many data, experimentation, and this has become what we call the fact. It is not opinion. This is what we call the sound science. Another thing that we also learned in this class, environmental science, which is we're going to try to use a type of thinking or logic is called the critical thinking. Okay. Inability to think critically, clearly, and analytically about a problem may be the most valuable skill you can learn. Critical thinking is the term we use to describe logical, orderly, analytical assessment of ideas, evidence, and arguments. Okay? If you ask, how do I know what I just said is true? Then you are maybe practicing this critical thinking, because you actually try to base your opinion or what you say. Okay, we try to find the data or the fact of that opinion or what you just said. Okay, how do I know what I just said is true? So you kind of practicing the critical thinking already. Okay, so there is several components in critical thinkings. The first one is analytical thinking. So this analytical thinking helps you to break down a problem into many constituent parts. So we have a big problem, for example, then we can divide this or break down this problem into smaller parts. This is what we call the analytical thinking. And then there's a second component is creative thinking. How might I approach this problem in new or inventive ways? So this is kind of creative thinking. And then the next component of critical thinking is logical thinking. Okay? This evaluates whether the structure of your argument makes sense, logical or not. And then the last one is reflective thinking. Usually asks, what does it all means? So these are the four components of critical thinkings. Again, these critical thinkings will help you to learn about the environmental science. In this course, you will have many opportunities to practice critical thinking. So we will do the observation, we will perform experiment, we have the results, and from the result, then you can think what is actually happening, why it is happening, how to solve this problem, how to reduce or mitigate the problems, and etc. Yeah. When reading your textbooks, hearing the news, or watching television, try to distinguish between statement of fact and statement of opinion. Watch for cases in which you need to think for yourself and use your critical and reflective thinking skill to uncover the truth. Okay? Don't just believe what people say, but you have to think whether what they say is opinion, just opinion, or whether it is facts. So you can observe, you can try to find the proof, okay, about what that people say. Okay, critical thinking evaluate premises, contradiction, and also assumptions. Okay, I think that's all the chapter 1 that we have. And there are some takeaway points from this chapter. First, we learned about environmental science, which is an applied science. Okay, this is an applied science. This environmental science gives us useful tools and ideas for understanding both environmental problem and solution. So this is what make the environmental science become the applied science. This is not just pure science, but this is an applied science. We face many persistent environmental problems, but we can also see many encouraging examples of progress. So far, there are several progress in environmental science. For example, in the United States, the US EPA Water Clean Act 1972 is considered as one of the successfuls in the success in the environmental science, which is create the water, the conditions in United States that is fishable and also swimmable. and also part of our best or better source for the drinking water. This is the Clean Water Act. This is one of the success in the environmental science. Another success, for example, the national park, the refugee park, the conservation area. There's also some other success in the environmental science that encourage us to do more to solve more problems in this natural system. Resolving these multiple problems together is the challenge for sustainability. So this is actually the main theme of many environmental science right now, how to sustain the resources for our future generation, how to use the resources, but still make that resources available for our future generations. That's the sustainability. Science gives us an orderly, methodical approach, which is the scientific methods to examining environmental problem. Okay, so this the takeaway points from chapter 1. Okay, so I will see you again. Goodbye.